Hi everyone, my name is Justin Wood. I'm going to be talking to you today about tick-borne illness, scope, and epidemiology. A lot of this is going to come from data that we've been collecting at my company. I'm the founder of Geneticks, which is Canada's first private tick testing company. So a lot of what I'm going to talk about is data we've collected. Basically how the service works is people that are bit by ticks or their companion animals are bit by ticks. They submit those ticks to us at our laboratory. We test them for up to 17 different tick-borne pathogens. We return a report of the results to them or their physician, and then they can use that to inform what their medical interventions are going to be following that. So that kind of gives us an opportunity where we actually collect a lot of data passively about what's happening in Canada with ticks, tick-borne pathogens, and sort of as a consequence of that, tick-borne diseases as well. I'm also a research associate at the Magnotta Lyme Disease Research Lab at the University of Guelph, which is run by Dr. Melanie Wills. And she's going to be following up my presentation with talk about some of the projects that she's working on there and some of the ones that we collaborate with at Geneticks as well. Okay, so to start, I think the best thing is to talk a little bit about Canada's growing tick problem. I know a lot of people are aware of this problem, but I want to start from the basics of this. So what are ticks? A lot of people think ticks are insects, and they're not. They're actually an arachnid. They're more closely related to a spider or a mite. And they're what we call an obligate parasite, and that means they have to feed in order to progress through their life cycle. So the ticks that we're dealing with, these are generally hard-bodied ticks, like we can see in the top right corner there. That's an unfed adult female black-legged tick, and that is the main culprit for transmitting most of the pathogens and most of the diseases that we have here in Canada. So in order for this tick to move through its life cycle, it has to take 3 blood meals, and that means for it to go from a larvae to a nymph, which is sort of a juvenile stage, it has to find a host, it has to feed on that host, drop off, molt to the next stage, and then it has to find a new host, feed on that host, drop off, molt to the next stage, become an adult, feed again, drop off, lay a bunch of eggs, and then sort of perpetuate the life cycle. So what you can kind of get from that is that there are lots of opportunities in this tick's life cycle for it to acquire pathogens from the environment and then pass them on to a new host. And problematically for us as humans is we are often that host that has the pathogens transmitted to us. So this is what really perpetuates the problem in Canada as we have these ticks. They're feeding, they're picking up pathogens, they're passing them around, and we are sort of an end point for that, and that's what makes a lot of us very, very sick. Climate change is probably the biggest driver of Lyme disease and other tick-borne diseases in Canada. And I don't want to get too deep into this, but basically the way you can think of it is as the climate changes, it's becoming a lot more hospitable to tick survival and tick reproduction. So a lot of people think that the biggest problem here is we're having warmer winters and that's not killing off as many ticks. But the reality is that ticks are not necessarily dying in the winter. What we're having is we're having longer seasons where they're active, where they can be host seeking, and that means more ticks are finding hosts, more ticks are moving through their life cycle, they're reaching the stage where they're reproducing, and each adult tick is usually laying 1,000 to a couple thousand eggs. So we have a lot of new ticks, and the tick populations are bolstering. And on top of that, we have this problem where ticks are actually coming into the country on the backs of migratory birds. So it was estimated that every year in the spring, about 50 to 175 million new ticks come into Canada on the backs of migratory birds. So we have this problem where more ticks are coming into the country, they're establishing, and then when they're here, more of them are making it through their life cycles and they're reproducing. And we have this warmer climate, which is allowing the ticks to move into new areas in Canada, which they haven't been in before. And at the same time, we have the reservoir species that carry these pathogens that the ticks pick it up from, moving into new areas in Canada as well. And you have this sort of wave of ticks and tick-borne pathogens, and as a consequence, tick-borne diseases moving through Canada. And the other thing that I want to talk about here is as the climate continues to change, Canada becomes more hospitable to other species of ticks. Non-native ticks and non-native pathogens are coming into Canada as well. One of the best examples, I think, for this right now is the Lone Star tick, which a lot of people are starting to hear about, and alpha-gal syndrome, which is basically an allergy that you can develop to red meat after being bitten by this tick. Traditionally, we didn't really see the Lone Star tick in Canada. You would see adventitious versions of it, maybe on the back of a bird or an animal that was migrating. It would come into Canada, you would see it, and that would be the end of the story. More recently, we're starting to see evidence that reproducing populations are establishing in Canada. And that means that these ticks will start to be here more commonly, we'll start to encounter them more commonly, and we might encounter the diseases they carry and the pathogens that they carry more commonly. And just to give people an idea of how small these ticks are, because this is part of the reason that they can transmit so easily, is these ticks are actually very tiny. You can see here a size comparison. So we have a couple of tick species, or tick life stages here compared to a dime. And I think the best way to talk about tick sizes is to say that the adult ticks are about the size of a sesame seed when they're unfed, about 2 to 3 millimeters. And then the nymphal stages, which is the juvenile, are much smaller than that. They're more of a poppy seed size, and the larvae even smaller than that. So you can see how this becomes a problem. We have a lot of ticks coming, new ticks. They're all very small. They're very difficult to see. It's very easy to contact them and not know that you have. So looking a little bit more at the disease here, this is data that I pulled from the Public Health Agency of Canada. This is their 2022 report on Lyme disease. And I won't go into it in too much detail, but basically what you can see here is over the last 10 to 12 years, there's been a pretty dramatic increase in the cases of Lyme disease in Canada. So starting in 2012, there was 338, and by 2022, there was reported 2,500, and by 2024, we were up past 5,000 cases in a year. To make this considerably more dramatic, the National Academy of Science, Engineering, and Medicine, they put out a report last year that estimated about 10 to 20% of people that contract Lyme disease will develop debilitating symptoms. So we have case numbers increasing. We have a percentage of those that are going to get very, very sick when they're infected, and they're not going to get better. And then to kind of drive that home a little bit more, the Public Health Agency of Canada put out a paper that talked about the estimated cost to society for dealing with these increased cases of Lyme disease and these debilitating cases of Lyme disease. And they estimated that by 2050, if things progress unchecked in the same manner they are now, that the cost to society would be somewhere between $500 million to $2 billion every single year. So we really have a big problem here in Canada with Lyme disease, and it's just getting worse every year. And we expect that trajectory to continue unless we can do something about that. So I want to talk a little bit about the black-legged tick. As I said before, this is the main vector for Lyme disease in Canada. This is the tick that we worry about the most. There's over 40 different species of ticks in Canada, but this is the one that is most problematic, and it's also the one that people are encountering the most. So the black-legged tick is responsible for transmitting Lyme disease, tick-borne relapsing fever, anaplasmosis, babesiosis, and the Powassan virus. And if we look on the right here, this is a graph of the breakdown of ticks that are submitted to us every year. And about 75% of the ticks that are submitted to us are black-legged ticks. And then we see about 15%, which are the American dog tick, which is a tick we're considerably less concerned about because it tends to vector less pathogens than the black-legged tick. But that's not to say it's a safe tick. There have been reports from Quebec and Ontario just in the last year of Rocky Mountain spotted fever being found in these ticks and transmitted to humans. And then we have a smattering of other ticks that are medically relevant. We have the western black-legged tick, which is a cousin of the black-legged tick that lives on the west coast in BC. It's sort of BC's answer to the east coast black-legged tick. We have the Rocky Mountain wood tick, which is, again, sort of a cousin of the American dog tick that generally lives on the west coast. And then we have the groundhog tick, which is able to vector both Lyme disease and Powassan virus, and another number of ticks that we find in Canada that tend to be less medically relevant, but are still concerning nonetheless. Okay, so I want to talk a little bit about distribution, and this is from data that we collect passively at our service. So basically, when people or their animals are encountering ticks and they're sending them to us, we're collecting geographic data about where those samples are coming from. So this gives us an idea of how the different medically relevant ticks are distributed across Canada. And the big thing that I would say from this is that if you look at this map, you can see with the light pink there, that represents Ixodes scapularis. That's the black-legged tick. This is the main vector. This is the one that we're most concerned about. And you can see that it's really, really strongly distributed across the Atlantic provinces, southern Quebec, southern Ontario, and then even up through northern Ontario into Manitoba and Saskatchewan. So there's really a lot of these ticks around, and these are conversely in a lot of the areas that are most densely populated by humans. So we're having a lot of interaction between the black-legged tick and humans. The black-legged ticks are vectoring all these diseases, and this is these pathogens, and this is help pushing these diseases along. On the west coast, we don't really have very many black-legged ticks, but instead what we have is the western black-legged tick. This can also vector pathogens, but it tends to vector them at a lower rate than the Ixodes scapularis does. So though it does contain pathogens and it can transmit them, they tend to have about half the number, or half the percent infection prevalence as the Ixodes scapularis does. And then we also have Ixodes cookii up there, which is the groundhog tick. This is another vector for Lyme disease and other pathogens. And you can see that it sort of shares a range with Ixodes scapularis. This is looking at those same black-legged ticks, except for this time we're looking just at the ones that are carrying different pathogens. So on the top graph here, this is just Ixodes scapularis that test positive for Borrelia burgdorferi. And that's the pathogen that causes Lyme disease the most in Canada. So we can see again that there is a high concentration of ticks carrying Borrelia burgdorferi in the Atlantic provinces, through Quebec, down through southern Ontario, again, and then sort of a smattering of them up through northern Ontario and into Manitoba. We don't see a lot of Borrelia burgdorferi from ticks that are submitted from the prairie provinces in Saskatchewan and Manitoba. And then again, when we get out to BC, where we have the western black-legged tick, again, we see some infection with Borrelia burgdorferi out there, but not quite as many ticks, or not as high of a percentage of those ticks are carrying it compared to the black-legged tick in Ontario. And then on the bottom map, this is a breakdown of some of the other pathogens we see. So in blue, we have Babesia autocoelii, which is a probable agent of human babesiosis. We have Babesia microti in pink, anaplasmosis in black, and Borrelia miyamotoi, which causes tick-borne relapsing fever, in orange. And again, you can see that these, the distribution of these, again, is pretty concentrated in the Atlantic provinces, southern Quebec, southern Ontario. This is where we really see the worst problem with ticks and their pathogens. And then again, we do see in the coastal ranges of BC, in particular on Vancouver Island and the coastal areas, some concentration of these pathogens as well. Okay, so this is a breakdown of the infection prevalence of black-legged ticks submitted from across Canada. And we have 5 different pathogens represented here. We have Borrelia burgdorferi, which causes Lyme disease. We have Borrelia miyamotoi, which causes tick-borne relapsing fever. Anaplasma phagocytophilum, which causes anaplasmosis. Babesia microti and Babesia autocoelii, which cause babesiosis. And then on the last chart there, we have Bartonella species, which in theory cause Bartonellosis. And we have 5 different years represented here. So each column has 5, or each category has 5 columns associated with it. And these are representing data from different years. So the first column is from 2020, and then we have data all the way up until 2024. And what I would say is most important from this graph is you can see that Borrelia burgdorferi, that causes Lyme disease, is by far the most common tick-borne pathogen in Canada. And we see that in about 27% of black-legged ticks that are submitted to our service. And you can also see that the prevalence of Borrelia burgdorferi in black-legged ticks in Canada has been increasing pretty much every year since 2020, where our data starts. So in 2020, we had about 21% of black-legged ticks testing positive for Borrelia burgdorferi, and by 2024, that had increased to just over 27%.
Sorry, Justin.
Yeah.
We can't see from here the pathogens.
Sure.
And I'm very curious about autocoelii. Where is it?
It's the second to the last one.
Do you have a
Point. This one here.
Oh, okay.
Yeah.
It's really,
Yeah. So that will be my.
is it published?
It's on our website. Yeah, I can give you the link later. Yeah, so that actually brings me right to my next point, which is Babesia autocoelii is actually the second most prevalent pathogen that we're detecting in black-legged ticks. And we're finding generally over 10% of the black-legged ticks submitted to our service carry Babesia autocoelii. And I think quite interestingly, Babesia microti, which is generally considered the main cause of human babesiosis in Canada, is actually very rarely detected in black-legged ticks by our service. And I've seen this in the literature as well. It doesn't seem to be particularly prevalent, but Babesia autocoelii is showing up a lot. And then we have the other pathogens, Borrelia miyamotoi and Anaplasma phagocytophilum, which are showing up in less than 2% of black-legged ticks submitted to us. And lastly, I know there's a lot of people that talk about Bartonella and they consider it a tick-borne pathogen, and this is something we've been looking for in black-legged ticks for over 8 years, and we've yet to find it in a single tick that's been submitted to our service. And I think this is also sort of very similar to what I've read in the literature, which kind of indicates to me that Bartonella is unlikely to be a tick-borne pathogen, but more of an opportunistic pathogen that shows up in people with symptoms of Lyme disease.
Uncanny?
Yeah, Duncanny has been excluded from this as well. We test for it every tick that comes through, and it's the same. We haven't detected it in Canada at all. We expected to find it on the West Coast, and we've never found it in any ticks from BC so far. But we do test for that as well. Okay, so this is looking at the seasonal activity of different ticks' life stages for black-legged ticks, and I think this is important because this can help people assess when the riskiest times of year are and when they're most likely to encounter people with acute symptoms of Lyme disease, and that can help people make early informed diagnoses so that they can have early treatment options. So on the left, again, this is data just from our company, and this is a breakdown of the percentage of total submissions that come in each month for each life stage. Sure, yeah, they told us not to use one, but I can use this one. There we go. Okay, I think I'm going to get in trouble for this, but we're going to do it anyways. So in dark green here, this is the adult Ixodes scapularis ticks, and we can see that there are two main peaks of activity for Ixodes scapularis. We have a first peak in the spring here from April, May, and June. And basically what's happening is as the snow melts away and temperatures start to warm up, these ticks are coming out of the leaf litter where they've spent the winter, and they're trying to find a blood meal. So they have high questing activity here, and this is also when people are starting to come out from their hibernation, and they're getting out into the environment, and they're starting to walk around and encounter ticks as well. And then as it gets hot, these ticks don't like to be out, this life stage doesn't like to be out and active, so their activity starts to decrease through the hot summer months, and then when we get into the fall and it cools down before winter, they're looking for a second blood meal, and they'll have a high activity again through October and November, and even a little bit into December before it gets too cold. On the other hand, we have the black-legged tick nymph, which is the juvenile stage. This is the very small stage, you'll remember, and they actually have the opposite activity. So as it starts to warm up in the hot summer months, the activity of these increases, and they come out from May, June, July, August. And they start to be very active in that period when the adult activity goes down. And I think that this kind of highlights something important if we look at this compared to the number of new Lyme disease cases diagnosed each month, you'll see that Lyme disease is disproportionately diagnosed in June, July, and August as well. So what you'll notice is that this actually coincides very well with the nymphal tick activity. And the literature supports the idea that the nymphs are the most dangerous stage, and this is because they're very small and they're very hard to see. So you can imagine, again, if you look down and you have any freckles, that's about the size of an unengorged tick nymph. It's very, very difficult to go out in the outdoors, very easy to go out in the outdoors, get bit, not notice, and then not find that tick for a couple of days at a minimum, or at all in a lot of cases. And the other thing that you'll notice is that this is the time that Canadians are most active in the outdoors, when things are warm. So again, we have this perfect storm. We have ticks that are very, very hard to see. They're very active in these summer months. And at the same time, we have Canadians out in the environment kind of doing everything that they want to do when it's too cold. Okay, so I want to talk a little bit about affected demographics. Again, this is data that I pulled from the Public Health Agency of Canada's website. And they show a bimodal distribution of ages that are most affected by Lyme disease. So they show one peak between 5 and 15 years old, and a second peak between about 60 and 69 years old. And they said that the average age of affected individuals was about 47 years old, and there was a slightly higher incidence in males than in females, with 55%-ish of affected people being male and about 45% being females. And we found this pretty interesting because we actually took our data and we looked at the people that were being bit by Ixodes scapularis ticks and sending them to us, and we saw a very similar distribution pattern. So we saw again that disproportionately the very young children were being bitten the most by Ixodes scapularis and then sending those ticks to our service. And then we saw another peak around 55 to 69 years old of people that were being bit by these ticks and sending them to our service.
Excuse me,
Yes.
Can I ask you, Deb Martin from Barry?
Oh, hey, Deb.
Hi. I'm wondering where you're getting the stats from for diagnosis of Lyme.
Like this graph here? Yeah, so this all comes from the Public Health Agency of Canada. They put out a report on Lyme disease in 2022, It's on their website, and then they have some follow-up for the years after that.
It has to be reported to public health in order for them to know.
Yes,
and
exactly.
they're getting completely underreported.
Yeah, that's the point that I should make as well, is a lot of what we're talking about here I think is well underreported, but we kind of have to take it with a grain of salt because we only have their data to work with.
Yeah, no, I understand.
Yeah, no worries. Yeah, so again, what I was saying is we see a pretty similar bimodal distribution pattern, and I think this is just basically talking about what demographics are most at risk. It's the same people that are out encountering these ticks, obviously, that are getting Lyme disease. And what I suspect is these are the ages where, the very young are out playing in the grass, running around. They're encountering ticks that way. And then we have, as we kind of get into the older adult population, I think people that are out more doing things like hiking, hunting, fishing, gardening, all these at-risk activities. And in these younger ages, I think that there is sort of more people that are spending more time inside on their cell phones. They're a little bit less at risk than these other demographics. And I'm sure there's also some issues with willingness to report, people that are finding ticks and they're just throwing them off. They're not reporting symptoms to their doctor. But yeah, we do have this shared bimodal pattern with the people that are getting sick as well as the people that are encountering these ticks. And then just to kind of follow up on that, this is some risk activities. So again, this is self-reported. This is people that are submitting their ticks to our service. We generally ask them, what were you doing at the time where you think you encountered this tick? And you have to take it with a grain of salt because not everybody knows when they've encountered the tick and they don't know what they're doing. So they might look back in their history and say, oh, well, I was in the forest 2 days ago. That's probably where I got the tick. But it could have been a number of other places in between those times. So overwhelmingly, almost 75% of people reported that they were doing some type of outdoor recreation when they encountered the tick. This is really unsurprising. This includes things like hiking, fishing, hunting, mountain biking, anything like that that put them out in the environment. And then the next highest category was yard work or home care. So this included things like gardening, landscaping, raking leaves, that sort of thing. And then some smaller categories for pet care and for outdoor industry, things like reforestation, deforestation, that sort of thing. And somewhat alarmingly, close to 15% of people said they had no idea what they were doing when they were bit by a tick. A lot of them didn't even know they were bit by a tick, and then they look back through their history and say, well, I haven't done anything risky in the last 2 days. I sat in my backyard with my friends, or I went for a walk in the park. So you kind of have to understand that ticks are being encountered not just in the places that you think are highly risky. You don't have to be out deep in the woods bushwhacking to encounter a tick. It can happen in your backyard. It can happen in your local park. Anywhere that migratory birds and animals go, you're likely to be able to find ticks as well. Okay, so one of the last things I want to do is do a little comparison between some of the different ways that we've collected data. So I actually found on the Public Health Ontario website, they have data for their active surveillance for tick testing, and they have reported incidents of Lyme disease, and they have this all broken down by public health unit, which is really great because we have very similar data from the way that we've collected this data. We have it broken down by public health unit as well. So just to give you a quick understanding of active versus passive surveillance, active surveillance is going out into the field and dragging for ticks, sampling for ticks, and then sending them back and being tested. And passive surveillance is more of what our service does, where people are sending us these samples passively, and then we're testing them and we're kind of building these databases. So this is a chart that's comparing these different types of data collection. So on the left, we have infection prevalence, the number of black-legged ticks that are infected with Borrelia burgdorferi. And in blue, we have the data that's collected by Geneticks through passive surveillance. And in purple, we have the data collected by Public Health Ontario through active surveillance. And then on the right, we have the Lyme disease case rate in humans, which is the number of Lyme disease cases per 100,000 humans. And that's this blue line here. So the first thing I would say is just when we look at Ontario as a whole, we actually really see good congruence between the data collected passively through Geneticks and the data collected through active surveillance by Public Health Ontario. We see pretty similar infection prevalences, and we see the same trend of the infection prevalence increasing from 2020 to 2024 in both sets of data. And you can see that this correlates quite well with the incidence of Lyme disease, which has also been increasing from 2020 to 2024. So I think a lot of the data is really kind of telling us the same thing here, which is, again, we have this increasing problem with ticks, and that's driving an increasing problem with Lyme disease in humans in Ontario. But I think this gets a little bit more interesting when we break it down by public health unit. So this is maps that we generated using a tool, a Public Health Ontario tool called Easy Maps, and it allows us to put in the infection prevalence here in purple based off of the passive surveillance data generated at Geneticks, and we can break that down by each public health unit. So we can look at this and we can say, okay, this is the Kingston-Frontenac Public Health Unit, and over 50% of the black-legged ticks from this unit tested positive for Borrelia. And then we can look at some of the adjacent public health units, and we can look at how sort of fragmented the landscape is. So I talked earlier about the infection prevalence in Ontario being about 27%, but if we break this down by public health unit, you can see that some areas in Ontario are significantly worse than other areas in Ontario. So there are areas where when you're out there, you're more likely to encounter ticks, and they're more likely to carry pathogens. And on the left here is breaking down the case rate of Lyme disease in Ontario, again, based on public health units. And what I find really interesting about this is our passive surveillance data correlates really well with the case rate. So unsurprisingly, places where we are detecting more humans encountering these ticks and then sending them to our service and them testing positive is correlated really well with the regions where more people are being diagnosed with Lyme disease.
Is this just case rate or case rate per population?
This is case rate per population, yeah.
It is on your site too?
Not this one, but this is in the handout, so in the slide deck, yeah.
Where is Sandbanks there?
Sandbanks, I think, is in this area here. Yeah. Okay.
Prince Edward County,
Yeah.
a nice wine place. It's not good for this.
Yeah. And then just to do a little comparison, this is then the active sampling, which is done by Public Health Ontario. And this doesn't do as good of a job of predicting which areas are, it doesn't correlate as well with the data on incidence of Lyme disease. And this is probably for a number of reasons. One is active sampling, you have to choose where you go out to sample. So if you don't go out and sample, you're unlikely to get data from that area. But also, the other thing you have to imagine is through passive sampling, you actually capture the interaction between humans and ticks rather than just ticks and the pathogens they carry. So sorry, somebody? I thought I heard somebody. So in this case, people have gone out. This isn't representing how often people are encountering the ticks, whereas when we passively collect through our service, we are actually collecting the data that people are in those environments, they're crossing paths with ticks, those ticks have a high infection prevalence, and that's why I think it correlates so well with the Lyme disease case rate throughout Ontario as is sort of fragmented in these public health units. So all of this can be used to kind of get an idea of where you're more likely to encounter ticks that carry Lyme disease, and it can be used to help people sort of inform the risk within Ontario.
How does public health get their information?
This is data collected over the last 8 years, so most of our sample sizes are quite large at this stage. They're usually in, like 50 to hundreds of ticks per area. But there is, if we look just in, if we look just like per year, sometimes we do have that happen. We might have one tick submitted from, let's say, like Thunder Bay, and it tests positive, and it looks like 100% infection prevalence, and obviously that's incorrect. But at this stage, most of our sample sizes for each of these units is quite high. So I think the infection prevalences are a little bit more, we can be a little bit more confident in them as the sample sizes are larger. Okay, yeah, I have one last slide that I'm not going to talk about because I'm out of time, but basically, if you look at these, there has been some literature around using tick bites to inform clinical management of Lyme disease. This was something that was kind of pushed aside for a long time. I think is starting to gain more traction that you can use human biting ticks to inform clinical management for people that you suspect having Lyme disease. So that's where I'm going to leave it for now. So thank you very much. This is just some of the lab members we work with and our collaborators. And if anybody's looking for any of this data, these are the references. You can find them and you can hunt it down on our website and in various other places as well. So thank you very much.